Matrix inversion method. In this module, you will learn how to solve a system of two linear equations with two unknowns using the matrix inversion method. We can do various operations on matrices like addition, subtraction, multiplication, and matrix inversion. Now let us see how these operations are used to solve a system of linear equations. We know that two or more linear equations with the same variables form a system of linear equations. The simplest system of linear equations has two equations and two variables. Consider this pair of linear equations in two variables x and y. If we write the coefficients of x and y in a matrix and the variables x and y in another matrix, the product of the two matrices shows the left-hand side of both equations. The right-hand side of both the equations can be shown as a column matrix containing 2 and 3. On multiplying the two matrices and using the concept of equal matrices, we get the same equations. Thus, this matrix equation represents the given system of linear equations. If we name the three matrices A, X, and B, we get an equation AX equal to B. If we know the inverse of A and multiply both the sides of this equation by the inverse of A, we get an identity matrix into X equal to A inverse B. This is because the product of a matrix and its inverse is always an identity matrix. The product of an identity matrix and a matrix X is the matrix X itself. Thus, X is equal to A inverse B. Thus, we can find the value of unknowns in matrix X by finding A inverse B. Recall that the inverse of a matrix exists only if the determinant of the matrix is non-zero. This is because the inverse of a matrix is equal to the adjoint of the matrix divided by its determinant. Here, the determinant of matrix A is 2. Hence, its inverse exists. To find the adjoint of matrix A, create a matrix of cofactors by writing the cofactor of each element in their respective rows and columns and name it C. The transpose of the cofactor matrix C will represent the adjoint of matrix A. Now, if we multiply the reciprocal of the determinant of A by the adjoint of A, we get the matrix A inverse. Now let us compute the product of A inverse and B. Since A inverse B is equal to matrix X, the value of X is 1 and that of Y is negative 1. This is how the matrix inversion method works. So we can solve any system of linear equations that has the same number of equations and unknown variables using the matrix inversion method. In this module, you have learnt how to solve a system of two linear equations with two unknowns using the matrix inversion method.